Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another edition of Red Hat Enterprise Linux Presents. I am Chris Short, executive producer of OpenShift TV, and I am joined by the one and only Scott McBrien. Scott, how are you doing today, sir?
Doing great. How's it going with you, Chris?
Well, it snowed overnight here, so I'm still waiting for spring.
I mean, it's April. Aren't we
It's
past that now?
April 20th, 21st. Yeah, we got like snow. It was enough, like further south, closer to the like Huron and everything, and the Ohio border. They got like 3 to 5 inches of snow, where we got 1 to 2. And it's like, wow, come on, lakes, give us a break.
See, here I was in the South being like, wow, it's windy today. That's
Yeah.
unusual.
No, it's like freezing cold outside. It's 37 outside Fahrenheit, and that's just 2 degrees Celsius if you're watching from another country right now. And yeah, that's just cold and windy and like just not fun. So yeah,
That's completely uncalled for.
I know it's like completely unnecessary. I don't see why we have to go through this. We should fix this. You and me right now. Let's do it
We
on
have the
the stream.
technology.
Yeah.
Perhaps there's a tunable for it.
Maybe, which brings us to our topic today, performance part 2, tunables and tuned. Fun stuff.
Yeah. So
I love tuned.
a couple weeks ago, we were talking about like all kinds of stuff in proc and
yeah, Proxys and all the other fun little directories. Yeah.
So we thought maybe we'd revisit that and talk about how that kind of ties together with tuned, which is a daemon for managing that. So how much do you know about tuned, Chris? Besides loving it, clearly.
I mean, I know it has a series of profiles, and I know those profiles are very well constructed for their use cases, but sometimes they're named confusingly, right? Like if I'm optimizing for network throughput, what does that do to IO? Right? Like there's some missing explanation that you kind of have to always figure out what is this workload kind of like before you set up tuned to do something. You can have tuned record, I understand, right? Like just kind of get some data and try and figure itself out. I feel like, is there a function for that?
Well, we do a recommendation. So
Yeah,
it'll look
that's
at
right.
a couple
right,
things and like choose or recommend which profile it thinks works the best for your workload. But yeah, you're right. In effect, like so we initially included tuned with rel 5. So it's been
around. Yeah.
But as we've kind of built up the profiles, one of the things that got added to it was the ability to base profiles on other profiles. So like a lot of our profiles now are based on throughput performance profile as their base, and then they manipulate from there. And so there's one called network latency that includes throughput performance.
Right.
But so you end up with kind of like this stacked pile of things that happen in your system, and being able to detangle that a little bit might be interesting.
Yeah, and so there's actually like I'm looking at my Fedora 33 host right now that I'm using in power save mode on a server because it's just me using it. I don't need the highest of bandwidth and capacity and everything else going on. It runs OpenShift just fine, and when I log into it, it does my workloads just fine too. So, I've set up a power save profile. But somebody else is going to be like, no, don't do that. You need, something, whatever for, because it's a virtual host, for example, or, because it is running OpenShift, it needs to be more latency performant or something to that effect. So there's a lot of different profiles and a lot of different ways to apply them.
Yeah. Well, and I'm guessing you chose PowerSave because you
my electric bill was really high 1 month. Yeah. My wife was like, why is the electric bill so high? I was like, well, I got that server. Let me tuned this.
Yeah. Because like throughput performance like cranks that bad boy up to 100.
Yeah. I mean, I trust me. I tested them all just as I was interested about fan noise too, because at the time my office was still in the basement, and if I could hear the server from across the basement, I knew something was wrong.
Why is it running so hard?
Yeah.
All right. So why don't I share the screen here? I've just got a VM that I've pulled up, and I'll probably have to refresh it about halfway through. Just because these boxes are.
Can you increase
transient.
font size on that by any chance?
Oh yeah, hold on.
There we go.
More better?
Yeah.
Okay. So the first thing, TuneD ADM is the administrative utility for TuneD. And so we can do things like list. And these are all the TuneD profiles that are currently installed on this box. And that's not all the ones that we have available.
No, there's more.
Yes, there's more.
That's the default stack.
Right. And so, for example, I was just monkeying around with one for Microsoft SQL Server, which comes from a different package. So
yeah,
let me just install that real quick. That's right. No, let's do a list. And then because something like TuneD MS SQL profile or TuneD profile MS SQL, I can never remember. TuneD profiles MS SQL. All right, so this RPM installs yet another TuneD profile that is for Microsoft SQL Server. And so now when I do the TuneD ADM list, there's that new one that I got. And the reason I installed this one is, one, to show that you can sometimes get TuneD profiles from other places. But also, we're going to take a look at this one. And I know that for RHEL 8.4, there's actually an update to this one. So I thought it might be interesting to kind of like take a look at what it is now, what it's going to be when 8.4 releases, and talk about why those changes were put into place. But so if we take a look at the RPM payload, so essentially we got a directory, one configuration file, and a man page for it.
Okay.
So
yeah, what's in there? Let's go see. And folks, just to let you know, right, like there's profiles for Postgres, Oracle, SAP HANA. I'm trying to see if there's any other database ones I see here. Obviously MS SQL, but yeah, like and you can get more from other places, right? Like if your database vendor has made a TuneD profile, you can install that too.
And that's something I think like ISVs don't completely buy onto, is that you can actually package not just like your ISV software for Red Hat, but you can bundle in these kind of RHEL or Red Hat distro specific things to help optimize the performance of your app on it. But anyway, so this is the TuneD configuration. You can see that this one in the main has an include of throughput performance, which a lot of our TuneDs will start with throughput performance and then make adjustments off that. And essentially how it works is whatever's the last sticks. So if throughput performance has a setting that conflicts with one here in the MS SQL TuneD, because the MS SQL TuneD was the one that was executed last, it pulled in all the throughput performance, and then on top of that, put on the things from the MS SQL TuneD. So whatever happened in the MS SQL TuneD, that's what actually is persistent on the system. A lot of these, like down here, excuse me, down here under the syscontrol section, these are those proc systunables that we talked about a couple of weeks ago, or actually maybe a month ago now, which are not persistent. So the other part of TuneD is there's a daemon that's run by systemd that will start at boot and then looks at the configured profile and applies it at boot time, so that even though we may have made these changes live and those changes are put into Proxys, which is not persistent, we're at least making those same changes every time the system is booted. All right. So you mentioned that there were a whole bunch, and we saw that there's the list when we did the tuned EDM list, and those are all just stored in the user lib tuned. There's a slash there. Directory, right? So this is where you put stuff when you make your own tunedies. And you'll see that this corresponds with the list that we got from the tuned EDM command. So where do you want to start first, Short?
I don't know. Let's start. Well, what is functions? I mean, what is that? What is in that file?
Good question. I don't know.
There you go.
All right.
Used in scripts and okay, good to know.
Okay, so you could put script content in your tuned, and this apparently is like already written script content that you can use.
Yeah.
So that's what this is.
Okay, cool. Let's dive into like, well, what is balanced? I mean, what does balance look like? How about that?
All right, well, let's see. All right, so balance is just kind of like a generic 2D profile. And so you can see things like the governor, the CPU governor is set to conservative or power save. So we're not cranking the CPU all the way up to full power mode. That's pretty much it.
Okay.
Yeah. So I think for most folks, they're interested in ones that are probably based on throughput performance. But before we get to that, because that's going to cover a whole bunch of layered ones. I also think these two are interesting, virtual host and virtual guest.
Oh, yeah, absolutely. Let's look at host.
Okay, so all right, so host is included or includes the throughput performance, and then it updates the dirty page cache ratio. Yeah. So when we have 5% of the system is dirty page cache, it kicks off a kernel thread to start writing that out to disk. This over here, the kernel sched migration cost. So if you move a process from one CPU to another, you lose all the cache that was on the CPU that you're running on before.
Right.
And for things like virtual machine workloads,
that's a big deal.
Yeah, like losing all that cache and having to restart it on another CPU is difficult. So they schedule this or create this cost that basically says, hey, here's how expensive it is to move to another CPU. So we try to keep things on the CPU that they're originally running on.
Nice.
And then this, forced latency basically says something about sleep state and power. Basically, we shouldn't do sleep state or power save settings.
Right, exactly.
Because we're a hypervisor.
Right. Okay.
Right. Conversely, virtual guest, which is what you'd by default run on a virtual machine. In fact, before I do this,
is your VM running?
I bet it is.
Has it detected itself as a host or guest? I mean, yep. There you go.
Remember, we like make a recommendation. It turns out that recommendation is applied by default on boxes where you haven't done anything, at least on RHEL 7 and 8. So this virtual machine got the virtual guest profile applied to it. All right. So again, including throughput performance. So we get whatever is in there. Okay. And then we're setting it up so that we keep more dirty pages in page cache than the default.
Right.
We set swappiness to 30. Swappiness is a value between 0 and 100.
Yeah.
That sets your affinity for using swap space. I think the default on a system is 40 or 50.
I think it's 50, unless it's changing real late.
Like
8 dot something, right? Like, yeah.
So we're making it less likely that the virtual machine is going to use swap.
which is a good thing because swapping to disk in a VM, well, you don't know what disk you're swapping to. It could be very low performance. It could be very high performance. You don't know.
Right.
And in theory, the system doesn't know unless it tries.
And in reality, like a lot of places, let's say you were a cloud provider instance. Cloud provider instances don't have swap space.
Nope.
So you could set that to 1 and probably be fine.
Mm-hmm.
Although if you don't have swap space, there's really nothing for it to swap anyway. So
right.
I actually would probably add something to here. Just give my druthers.
Because you smart. Yes.
I'll probably do that.
Yes. I always forget that I used to have to do that on the freaking command line so much.
Right.
So many times, so many years ago. Elevator no up.
Right. And this is especially interesting for a virtual machine because you're doing all your disk IO and you're sending it through the disk elevator for disk IO, which the default for RHEL 8, I believe, is deadline. Hold on, let's see.
Right cache. Cache type.
Oops.
No, there's something in queue.
Yeah.
There it is. No, never mind. Let's just do a find for elevator.
It is in here. This takes me a minute.
Is it read ahead?
No, read ahead is a setting.
Right.
Okay, so this is not what I wanted. These are tunables for the IO scheduler. Oh, there it is. Scheduler.
Yeah.
Good eye there.
That was Rapscallion Reeves. Thank you very much.
So this one.
Yeah, MQ deadline. There you go.
Yeah. So the default is deadline. Oh, actually, it looks like I need to change my tunable because there's no longer a schedule called no op. It is called none. With RHEL 8. And so the tunables that are in this this Q directory are ones that are germane for the IO scheduler. Well, actually, the ones that are down here in IO sched are the ones that are germane for that scheduler. The other ones are just generic for the disk device. So things like read ahead. So after you've retrieved a piece of data from the disk, how much additional subsequent data should you read? Because if you're dealing with file IO, you go and grab a block of a file. What's the likelihood that somewhere close in the IO queue is more blocks of that same file? So we can do things like set the read ahead to slurp in more data, expecting that we'll be asked for that data shortly.
Right.
Let me go back in here. Whoops.
So what is the throughput one?
All right, so let me finish this and then I'll
yeah. Sorry. Finish your tuning itch.
Yes. All right, so but I wanted to ask you this. So why would I set the elevator to none on a virtual machine?
Oh, I forget. Oh my God, you had to ask me that. There is a reason. And it is a reason. It is a huge performance hit. I know.
Well, it depends. So
well, for databases, for sure it is, right? Like, and this is where I'm used to setting it, right? If that makes sense. Yeah, MySQL servers, to be specific. So you tell me, man.
All right. So let's say that we kept the default of read ahead, right? So we have the disk IO queue and IO requests are coming in, they're being put in the queue, and then we're spending our time in the kernel going, oh, wait, this one is close to that one. Oh, this one's about to expire. And it's doing all this reordering on the queue. But then where does that go? From the virtual machine to the hypervisor.
Right.
And it turns out the hypervisor also has a scheduler that's doing the same exact stuff, but now across all the machines in aggregate. And so you spent all this time on the virtual machine making this order as best as you could, but when it goes to the hypervisor, it just gets reordered anyway. So why waste your time doing the disk IO ordering on the virtual machine, which is going to be reordered as soon as it gets to the hypervisor. Right. So that's why we set it to none, and it may not be the best for every workload. It also depends on like what all the virtual machines are doing and what the hypervisor is doing. There's a lot of things in play there. So whenever you make changes, you always want to kind of not just go, yeah, it looks good. It's like, no, we're going to put the change in and then we're going to try it out.
Yeah.
And we're going to measure some stuff.
Yes.
If it turns out the change doesn't do anything, then we can take it out. If it does something and good, we'll keep it in. If it does something and bad, we'll take it out.
Cool.
All right. So you were asking about throughput performance.
Yeah. I'm curious why that is underneath guest.
Yeah. It's underneath most of our stuff, honestly.
Oh, really? Okay.
Yeah.
Rapscallion Reeves asks, would that also affect any network shares or VFIO?
The
elevator
maybe VF. Well, so
maybe
it's whatever
not
disks
shares,
you have in block, right? So if your network shares don't show up as block devices and they /sys/block directory, no. Things like iSCSI devices would show up as disks, so it could potentially affect those. But there's also a regular expression that you can put in that disk subsection of your tuned that identifies which disks it should apply to. So if you are in a state where you have iSCSI devices and you don't want this to apply to iSCSI devices, you can use this regular expression syntax to make changes so that it avoids those iSCSI disks. In short, in our episode guide, I put in a couple of links that might be interesting.
Oh crap! You have an episode guide?
I know. I put it together like literally 30 minutes before the show.
Oh, did you send it to me?
Probably not explicitly. So there are two links to the same knowledge or to the same Red Hat product documentation. It's called something like the RHEL System Monitoring and Performance.
I know what you're talking about, but yeah.
And so one is just that guide, and the other one is to specifically chapter 3 of that guide. Chapter 3 talks about making changes to tuned profiles. And in there is like, okay, here's how you can make changes to the disk. Here's how you can, here's past the elevator. Here's how you can pass the regular expression. You can also pass other tunables, like we could actually set the read ahead in that disk section that would apply to, in my case, all disks, because I didn't limit it. But if you're regex limiting it, you can tell it what read ahead you would like to apply to that set of disks that are matching your regex expression. So hopefully I answered Rapscallion's question.
I think so. He says regex for the win. So it would affect iSCSI, not necessarily NFS.
Yeah, so NFS devices typically don't show up as disk block devices. So it naturally wouldn't affect those because they don't show up as the device type in sys.
Yeah, and you did not share a doc with me, by the way.
Oh, I am a complete failure in so many things.
Just doc sharing right now. So
let me see.
How all these other people have it, not me? Why don't I get access to this special fancy directory you have?
There's reasons. We work in different teams.
I know.
Okay. But I still love you, Chris Short.
Thank you. I appreciate the love.
Cool. So you should have that now.
I do. Thank you.
Okay. Awesome. And so we're talking about throughput performance. So we see a couple things. We're starting to introduce the idea of architecture-specific tunables. And so up here, This is for Marvell ARM processors.
Okay.
But we'll get more there. Here's an AMD one, and then there's actually settings later. In fact, you see right here the VM ThunderX then has a regex that says only do this on ARM, but only if you match that ThunderX CPU regex. Right. So it can get fairly complicated. Anyway, so a couple things in the throughput performance. One is we set the CPU governor to performance, meaning crank that up to 11, slurp up all the power, make it
minimum performance percentage.
100.
Yes, 100. Rock that thing. Yeah.
Right. So
disk read ahead greater or equal to, yeah, Jesus. Right. Okay. Wow. There's a lot going on here.
So we set the read ahead. So when we say virtual guest, and virtual guest includes throughput performance, cranks up the CPU governor, although on a VM that really doesn't matter, but it does set the read ahead to 4096 or greater on disks attached to the VM. Yeah. And then down under syscontrol, so we set the schedule granularity. So every 1 million USECs or something.
It says nanoseconds.
Yeah. It'll check to see whether we need to change what the scheduled job is on the CPU.
Right.
And then down here, we will check this many nanoseconds, whether we should make that decision or not. And then we set the dirty page ratio higher than normal. And you may remember that in the virtual guest, it toggled that back down to 30.
Right.
And then when it's 10% of memory is dirty page cache, we'll start up a job in the background to start synchronizing out those dirty pages. And we set the swappiness to 10.
Lower. Nice.
Yep. So in virtual guest, we then turn that back up and make it more swappy, more likely to use swap space.
I appreciate the documentation that's in here, right? Like the comments are actually handy.
that is somewhat newish.
Okay.
So that did not exist on RHEL 6.
Right.
It may have existed in some of the later versions of RHEL 7, and it exists in RHEL 8. We're looking at an 8.3 box here. Yeah, so we run through performance, and then on top of that, we provide virtual guest, and then whatever is done last sticks. That's our 2D profile.
What's the like inheritance hierarchy there? Is it if it call like obviously there's system like CTL settings you can set, right? And then I would assume those would override the tuned profile. But if the tuned profile has another file underneath, like where does do you know?
An excellent question. It's always whatever is done last sticks. So tuned starts up, and if you include a profile in your tuned, the included profile is executed first.
Okay.
And then your profile is executed on top of that. So in the case of virtual guest, the performance is executed first, and then virtual guest. And so that's why you're able to take like the swappiness from throughput performance and override it with a greater amount of swap space or affinity for swap space with virtual guest. Now, when we start talking about managing things through syscontrol, that like there's a whole nother angle into it.
That's a wrench that I wanted to throw at you.
Right. So I think that to make things simple,
I like that.
tuned works with both the syscontrol tunables and the /sys tunables, whereas syscontrol only works with the proc stuff.
Got it.
So I would say that tuned is the better way of managing performance settings because you're able to manage across multiple areas of performance settings.
Yeah, exactly.
Right. And then you obsolete the need to know about which one happens in which order. But essentially, if syscontrol is executed, in the olden days, that was done through an RC script.
Yeah.
And actually, I don't even know how it's done now. I haven't even looked on RHEL 8. But so wherever that RC script fell for syscontrol compared with the tuned service starting, that would determine which one was done first or last, and then would determine how messed up your intentions were.
I believe it is a unit file in systemd somewhere, so who knows? I could be wrong.
Oh, that's in
Etsy systemd, I think, or is it just system? I forget. Help me out, audience.
Why don't we just go here?
No, someone said something, but it's Rapscallion with this fancy Google.
It's fancy Googles. Oh,
I'm kidding. Is tunables rel specific, or will it work for other distros?
So it's open source.
Yeah, I mean, it's RPM based right now.
Yeah, it could work on other distros. I know the Red Hat distros all have it. So Fedora has it, RHEL has it, CentOS Stream, and Linux have it. And then, of course, the downstream distros of those would also have it. So Oracle Linux and the newer downstream distros that are starting up, like Alma, they'll inherit it.
Yeah.
All right. So, okay, here we go. This, I think, is the sauce right here. So the tunables service is started after systemd sysctl service. So sysctl will start up first, set all the parameters. Then tunables will start and overwrite those parameters with whatever's in your tunables if there's conflicts. So whatever is done in tunables is what sticks if there's a conflict. So there you go.
Yeah, all my Debian based distros are like Raspberry Pis and Nanos and such, so can't really find any record of systemd being available, or not systemd, tunables. But yeah,
not surprising. But
these are like, tiny devices that rarely get touched. So,
well, and the procsys and /sys, that's kernel stuff, right? So other distro uses the same Linux kernel, so potentially they could use tunables as well if they wanted to put in their distro. Yeah. All right, so I mentioned that that we have that MS SQL one.
Yes, I'm curious.
All right. So here's what's in the MS SQL one today. So it includes throughput performance. Basically, it looks at if you're using huge page memory, but through the running of things, you're not using a consistent memory space in the huge page, it'll actually copy it to a different huge page to congregate it better. And then down here, we're setting the memory map, like how big the virtual memory map should be. We do not use NUMA balancing. That's going to keep us from moving things between CPUs as much. And then down here, we're doing some kernel scheduling stuff, right? So we're determining the scheduled latency, the granularity of how often we need to wake up and check things, and how often we need to make changes to the kernel scheduler. All right, so let me edit this. And I'm going to copy and paste the new stuff. And you'll see this.
To confirm, there's several Linux distros that use tunables.
Good.
Or have it available. Debian being one of them. So that means all the other underlying Debian-based ones are probably going to have it available as well, which is cool.
All right, so this is the new stuff that's going to be in there. So we start off at the same starting point. We're going to start with throughput performance. We're making a slight CPU change for whatever force latency is. That's probably in /sys, I would imagine.
Yeah.
But you can see that, whoops,
whoa,
scroll too far. There's a whole bunch more syscontrol stuff happening in the updated profile that will drop with 8.4. So this is currently in the 8.4 beta. So we're changing the swappiness. So before we were just taking that, what swappiness is 40, that was in throughput performance.
Mm-hmm.
And now we're like, oh wait, no, we should turn that down for databases because that's pretty standard for databases.
Right. Like you don't want your database to swap. Trust me.
Right. Right. We're also adding in a whole bunch of page cache information, like how often we should write it, which in the earlier TuneD profile didn't exist. So we talked about this a little bit a while ago about how the set of background ratio, dirty ratio, expire and write back sentence X, that this is essentially an effort to keep as much unwritten file writes in memory longer so that we're not doing a whole bunch of disk IO on this machine.
Exactly. Because that will impact performance a lot.
You're right. So the other thing is we set transparent huge pages to always. I don't remember what the default is. We could check on this VM. But now we are going to always use transparent huge pages. In RHEL 7 and RHEL 6, a lot of times we defaulted to not using transparent huge pages, and that's starting to break loose in RHEL 8, where we're just better at allocating them and not delaying memory IO or memory requests, because behind the scenes we're trying to allocate these huge page to hand back. So apparently they've done some testing at between Microsoft and Red Hat and figured out that they can get away with this and actually improves performance.
Nice.
We're increasing the memory map size. So now per every process, we have more available map space. This was also not in the previous TuneD. So here what we're doing is we're changing the read and write memory settings for network IO.
Interesting.
So the default is how much a memory buffer should be in, I believe, bytes of RAM. And then the max is like how big you can make it. And write mem is the same thing, but for packets going outbound on the NIC. So it turns out that it's often the case that databases are running a standalone system, and they serve as a network connected resource for things like web applications. So the web app then makes a connection to the database through the network to try and retrieve that data at once. So we're buffing the network buffer sizes to be able to shove more data or read more data than when we receive those connections. All right, and then pretty much everything down here was already in the old TuneD profile. I think they may have changed the migration cost. Let's see. Yeah, there wasn't a migration cost setting in the old TuneD, so they added it, and it looks like the migration cost is actually lower than it was previously through throughput performance. So we're saying it's not that expensive if we need to take a database thread and move it to another CPU. My guess would be that it's because the database requests that come in are not contiguous parts of the read-in table space. So there's not a lot of expense if we switch it to another CPU because we're not losing the cache. There's not a lot of cache hits that happen from it.
Right. It's interesting that we use throughput performance so much. It's almost like, why isn't that the default as opposed to balanced, right?
Well, balanced isn't the default for a lot of stuff. Balanced is the default, I think, on like workstation installs. But
ye old Fedora profile says about balanced.
Yeah, I'll check my RHEL 8 physical machine real quick.
General non-specialized TuneD profile. That's helpful. Thanks. Let me go back over to my terminal here. No, really.
Okay, so my nothing special RHEL 8.3 laptop is running balanced by default. And if you look at the balance profile, it has stuff on like audio settings, and so I think it's more for like
Yeah, interesting.
desktop-y
Like
workstation environment.
yeah, exactly. Huh. Okay.
But yeah, so that's kind of how we build up a understanding of TuneD. The other one that might be interesting is network latency. That one we use a lot as well. At least on the server side.
Yeah, network latency is a big deal.
Right.
Especially if you do have classes of servers that do specific jobs that then hand off tasks to other things, big deal.
Yeah, and if you look at what it is doing here, it's called network latency, but it's really network low latency. So it includes latency performance, which is low latency performance profile. We turn off huge pages. So if something asks for a huge amount of memory, instead of trying to allocate a huge page and pass that off into its memory map space, we just give it individual memory addresses because there's time that's taken for those to resolve those huge page allocations. And then down here, it's looking at like how often we should check the network stack for its status. And then they also added the TCP fast open. So I'm trying to remember. I remember looking at this at some point, and something like we shortcut some of the TCP connection stuff, like the validation stuff, to just like have something going. Or maybe we keep a pool of connections or something weird. It was something weird that basically made receiving or sending TCP packets slightly faster. So, and last time we talked about how you could go into the kernel documentation and find out what the different tunables in Proxys were and the description of what goes in them. And maybe that would be a good exercise for that fast open to just refresh my memory on what it is.
Yeah, maybe. But, your box, yes, do me a favor. What is recommend.d?
Recommend
directory in there. Yeah, go into that directory, pull up the D profile. Because I just looked at it and it was very interesting to me. So obviously scroll down, but yeah, it's like it picks up the system purpose somehow or the chassis type and then defines, what the recommendation is. So like that balance thing would tell you on a desktop or a workstation, that's the recommended thing. But
yeah, actually, I bet right here is what caused me to be balanced.
Right, exactly. If you were not like, if you're on a server, for example, it would say, hey, am I a host or a guest? And then tune specifically to that. That I find interesting.
This one specifically is for which is like no longer a thing for Red Hat.
But if it sees that as a vert, it'll tune it to virtual guest.
Right.
Which I think is cool.
Yeah, down here.
Yeah, if you just say, like, if you're actually on the console, it'll say, like, this is recommended.
Yeah, in fact, I think TuneD ADM.
If you list it, I don't know if it says it. Recommend. There you go.
Yep.
Virtual guest. There you have it. All right.
That tells you what the recommendation would be, but doesn't actually set it.
Right.
It's not until you do a TuneD ADM profile and then assign the profile. So I can do something like
exactly. So there's logic in there to tell you, right? Like, but you can also change this for your environment and have something like Ansible come around and plop it down on the file system and say, you have a specific kind of hardware that needs a specific kind of profile, network latency versus, latency performance, or those two inherit each other. But, you get what I'm saying, right? Like,
so I'd go even a step further and say, remember like 2 or 3 months ago, we talked about system roles.
Yeah.
So one of the system roles is called kernel settings. And kernel settings lets you pass parameters. And what it's really doing behind the scenes is looking at the running tuned profile and taking those settings that you put in your Ansible playbook and sticking them in the currently executing tuned profile.
Interesting.
So that when you restart the machine and you get the last tuned profile you're running, your changes are still there from when you used the kernel settings system role.
That makes sense. Nice. Okay.
Yeah, so you don't even have to write your own Ansible playbook to do all this anymore. You can use the kernel settings system role, and it actually uses tuned for the storage method for keeping those changes persistent across your population.
Let's see if I can find that video before we get off the air here. Probably not. Well, it was just system roles, right? Like that was actually in. Let me just search for roles. I have to spell roles right first, though. Yeah, I found it. Here it is.
Cool.
It's got 10 likes, Scott. Good for you.
10 likes.
Yeah.
I'm a sucker for likes, Chris.
Well, wherever you're watching, please click like and subscribe if you can. But yeah, there's the system roles episode for those that are curious. Awesome.
So I don't know where else to go from here, Chris.
I don't either. I'm curious what the audience thinks, right? Like, how often are you changing sysctl settings? Would it make sense to make a system role out of that? Right? Like, or would it make sense to make a, profile? Or where is that line between system role and just another tuned profile, I guess, might be a good question.
Yeah. So I think that there's some thought to be had there. So I like the idea of using system roles because I can make changes to my playbook and then execute it across my population, right? So if it turns out that, I'm reading a tuning guide and it says, oh, we should go from swappiness of 1 to swappiness of 5.
Right.
I can go to my playbook and make that change and then execute the playbook, and the system role will then execute it across the population. If you have a diverse population, it might be that you only want to set the swappiness on databases, not web servers. So you can use the other Ansible stuff through inventory to make those determinations, right? And then you can have some conditionals in your playbook to decide this set goes with databases and this set goes with web servers. And then when you make your updates, you apply them to the correct subset of your population with the system role. So that, if given my druthers, that's probably how I would architect it.
So, okay, we might go on a spelunking mission here. Rapscallion Reeves asks, are there any specifics to tuning a container host as opposed to a VM host? Now, that is where it's like, well, let's go look at RCOS, see what it's doing. So
I have a feeling the answer is not really.
Probably not. Yeah.
Because unlike the virtual guests, where they have their own IO subsystem and a variety of other things, in a container host, you're sharing the same kernel as the host operating system. So number one, you don't get to change any of those things because in the container, you're not doing any of those things. And so I would look at something like maybe how you would tune for whatever workload your containers are generating on the box. So if your containers are doing,
Go ahead. No, your containers are doing, go ahead.
If your containers are doing a bunch of network protocol stuff, right? Because it's all web services. Maybe you would, on the host, make some changes to the TCP stack or the overall network stack to make it larger amounts of data that can push out. I think what you're probably more interested in on the container host is less tunedy and more C groups.
Exactly.
Yeah. So control groups, you can apply that to processes, and you can limit the amount of system resources that individual processes or groups of processes can consume. And that way you can make sure that no container takes more than its fair share of stuff on the box if you have a bunch of things happening.
Rapscallion Reeves, the place to go look to find this is actually in the OpenShift container platform release notes. So in 4.6, we did a partial TuneD real-time profile. And then now in 4.7, it looks like we've got some logic. If there's an invalid TuneD profile that gets created, the OpenShift TuneD supervisor process may ignore profile updates and fail to apply the updated profile. This bug fix keeps state information about TuneD profile application success or failure. So now OpenShift TuneD, which is a process, recovers from the profile application failures on receiving new valid profiles. So apparently there was an issue with TuneD between versions, and we fixed it. And there's a BZ linked in the 4.7 notes here. So yeah, there's definitely tuning happening in the OpenShift world for sure, which means that's happening on the RCOS nodes themselves, which are part of OpenShift.
And I have a feeling that like the
like if
MS SQL profile, it's like keeping dirty pages in memory, so you're not burning a bunch of cycles, writing stuff out to disk, and then also making sure that you don't move schedulers, because not schedulers, move CPU, because if your container was executing on one CPU and had all the cached information there, moving it to another CPU would be not great for it, because you'll then have to spin up a whole bunch of more cached information.
I'm such a dunce. I was trying to do an OCD bug to figure out where it is in the file system, but give me a second. But I don't want to leave you hanging either, Scott. So,
oh, it's cool. One other thing that you might take a look at is the, at least for RHEL, is BCC tools. So BCC tools uses the eBPF in-kernel virtual machine to slurp out real-time data from the running kernel. And we have things like cache hit and miss reporting data. So you can kind of see what's happening at the app layer while your applications are running. That might be useful, especially in a place where you have multi-tenancy for different container applications running.
Wow, my OCFU is failing me today. But yes, you're absolutely correct. Let's see. Will this work, please? No, it doesn't work because you're not typing it right. I give up. Anyways, if you do an OCD bug on a node, you'll land on the file system of that node, and then you should be able to then go find that TuneD profile for whatever it may be. So if you're super curious, go grab one of your OpenShift nodes and debug it real quick, and you'll find it. It'll be in a similar location, like userlib TuneD. I just can't get into these nodes right now. Oh, because they're in a not so fun state. Oh, my node's upgrading. Duh. That's why it's not working.
That would do it.
That'll do it.
Short, I did throw in one more link in our document.
Okay.
So this is one of the lab.redhat.com labs. It masquerades as a SQL Server lab. In fact, its name is SQL Server CStore. And it does two things. One is it shows you that when you're using Microsoft SQL Server, or really a lot of different databases, using column stores will save you effort when you're doing queries. But the other thing that it does, and this is the more like RHEL interesting thing, is it starts off by running a CPU dist BCC tool against the MS SQL query process. Right.
Fancy.
It's actually like, if you look at the command that my coworker Don wrote for it, it's like, wow, that's a big command. But the histogram that it produces shows you like where in the context switching, like how long jobs are running on the CPU, right? And all of them are kind of right at this one plateau, or a lot of them are at this one segment of time. And then the lab has you apply the MS SQL TUND. And one of the things that MS SQL TUND does is change the scheduling granularity. And then you rerun the same query with CPU dist. And what you'll notice is that all of a sudden, instead of everything being in a line at this one time, you get this much nicer gradation of context switching, because we're checking more frequently. And when a query resolves quickly, we can go ahead and put another query on the CPU. Or if a query takes a little bit longer, it might be like 2 or 3 checks, and then we can switch it. And so that's a real life example of where doing things like schedule granularity can actually have an effect. And you can visually see that with that BCC tool histogram.
Nice. Very cool. All right. Well, I mean, we're 14:57, man. We still talked an hour.
We did it. Yes.
Yay. Mission accomplished. Hang up a banner. Cluster failed to upgrade. All right. That'll be fun to debug later. As if we didn't have enough to do.
Crucial problems. They're tough to have.
Exactly.
So should we also let them know about our slight change in format? So it had been that we were doing a guest every couple of weeks for every episode. And I think that we're going to go to a format where we're doing a guest every other episode. So next episode, I'll have to find a guest to talk to us, which usually is not a problem. But then after that, what did we say? We're going to talk about file system stuff?
Yeah, I think we're going to go through the acronym's failing me, the standard Linux file system stuff.
File system hierarchy standard.
There you go. That was it.
And then I think that might parlay into just like a brief introduction to SE Linux of things where we expect them and everything just kind of works. And why is that?
Right. Yeah. Why did we do things the way we did it?
Yeah. So what we're going to do, or we're going to try for the next while, is we'll have a guest one episode, and then we'll do something like this, more free form, digging down in the OS for the next episode. And then we'll go back to a guest, and then we'll do free form excavation in the OS.
Yeah. Eventually we need to get like a fleet of OSs to go mess with. So I can make that happen.
OSs.
Well, not, I mean, like, give me like 5 rel boxes. What can I do now? Right? Like, build, maybe lay out an app, right? See what happens. All the things we've learned and apply it. That could be fun.
Could be fun. I've got a set of 3 that I can spin up for 30 minutes at a time. But
I got whatever I want in my basement.
Fair enough.
But anyways, great show. Like, learned a lot. The inheritance, all the last applied stuff. Somebody wants an Ansible workshop. I mean, we could do like an intro to Ansible on RHEL kind of thing if you want.
Yeah, I could ask Sean to come over and be our guest.
Yeah, I could ask too. I used to work with him, But yeah, the Ansible channel does do stuff on a regular basis too. So if you haven't seen the Ansible YouTube, go find it. It's they're doing some new stuff with it lately. So yeah. But Rapscaling Reeves, if you want some Ansible content, we can make that happen for sure. So yeah, that's it for the streaming on the air today. Tomorrow we start bright and early, 0900 a.m. Eastern. We're going to be talking about storage, but what happens with failed migrations? What do you do when bump in the night does happen during your massive migration of workloads or storage in this case? So yeah, that'll be an interesting little adventure that Eric Nelson, Michelle De Palma, and I will be on first thing in the morning tomorrow. And it's a pretty full day. So, check out the calendar when you get a chance. Sign up for Red Hat Summit. It's very free. I highly encourage you to go take advantage of that. And yeah, have a great day out there, everybody. And if I don't see you the rest of the week, have a great week.
Thanks, everybody.
See y'all.